Fantastic. Okay, yesterday we did the experiment with the air. All right, so what was the question from yesterday? Henry?
What happens to volume of air when it is heated, when it is cooled?
Okay, what happens to a volume of air when it's heated and when it is cooled? So we're gonna do some vocabulary, and we also need to modify our diagrams. So be willing to change a little bit, okay? I'm just gonna draw my volume of air in circles as the container to keep it simple. So inside, we've got, I'm gonna draw 10 particles. 3, 4, 5, 6. Why are you talking? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I got 10 air particles in there. Okay. Checking to make sure I can see that. Good. Then I'm going to draw 10 air particles in here. I'm gonna make that a little bigger. But it's gonna be a smaller volume. And so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're really all different sizes. They should be the same size. All right. So 10 air particles in each. All right. This is when we placed it in the hot water. Good. And this is when we placed it in the cold water. All right. And so what happened when we did the hot water? Yes, ma'am.
The air tried to escape, but it couldn't because it was sealed.
It was trapped in there. And so what was the result of the bottle? What happened? Yes, sir? I'm looking for a vocab word. Okay, so it expanded the bottle because the air particles. Yes?
Were compressed.
No. It expanded the bottle because the air particles did what? Sawyer?
It moved more.
Vocab word. It expanded the bottle because the air particles. Yes, say it louder.
Expanded.
Because the air particles expanded. Okay, we're going to write formal definition like this. Expand or expansion. Write this down, please. Expand, expansion. And so we're going to describe it as move away from. Notice I didn't say get bigger. Why do you think I didn't say get bigger? Yes, ma'am?
Because when like you stretch a rubber band, it gets bigger and it expands, but in some cases, when it gets bigger, it is expanding.
So in this case, the bottle's getting bigger, but we're talking about air particles. So what are the air particles doing? Are the air particles expanding themselves?
They're going fast.
But are the air particles changing size? No. So that's why I said move away from. The air particles move away from each other because they are moving faster. All right, any good diagram has labels. So now I've labeled it hot and cold, which hopefully you have. Jefferson, move. End of the table. So what I really need to do too is say that these air particles are moving faster, right? And so in the cold, the air particles are moving slower. You have these labels on your diagram. If you don't, please add them. We are modifying our diagram and recording vocabulary. Now, you said the air particles are moving faster. This is actually a measurement. When we are talking about the speed of air particles, how are they moving? What is that? It is a new vocab word, but I'm sure you've heard it before. Speed of air particles, we are talking about what? Raise your hand, please. If our particles are moving faster, if they're moving slower, we can say they have a high or a low what? Yes, sir. Vocab word. So a word that you may have heard before that we're going to define. Go ahead, Allison. Nope.
Oh,
Kinetic energy. Please say that.
kinetic energy.
All right, kinetic energy is defined as, write this down, energy of motion. Write this down. Yes, sir.
Is that really? Yeah, kinetic sand.
Yeah, a little bit. All right, kinetic energy is the energy of motion. Write that down. So now that you have this written down, let's talk about a good diagram. A good diagram shows a process. How are we going to show kinetic energy in our volume of air? I guess I should label too. Okay, yes. These are air particles, so I am going to label that. All right, and this is air particles. Okay, and you said arrows. Great. How should I draw my arrows? Sir.
In the one, you should draw the arrows longer, and in the old one, you should draw them shorter.
Okay. So I will do an arrow here, but here's my problem, right? If I've got these arrows here, right? And so these are all different, but then some of these arrows are kind of going to be the same size. Like this arrow could potentially be like the same size as some of these arrows, if not longer. Here's a question. Are both volumes of air bouncing against each other?
Yeah,
Yes. And are they bouncing in any direction?
yeah.
Yes. So they're not just all like, you know, bouncing up or down or whatever. Like they are going, and they're also like running into each other, right? So all of these guys are like, it's just all willy-nilly, right?
They're just moving slow. The cold is just really slow.
So how do we indicate with arrows that the cold ones are moving slow? What could we change to indicate that these are moving fast and these are moving slow? The length of our arrows, it's really showing a direction. And if they have more space to move, they're going to do that until they run into something, right? So our arrows can't always indicate that. All right, so what do we change? Can I make a suggestion? You ready? Okay.
I'll make it 6.
You're making them bigger in a certain way. Does that make sense? No? Who said that? Let's talk. Okay, I'm making them bigger to indicate faster means more what? More kinetic energy. All right. So go ahead and adjust your arrows in your diagram. Do this now. Change your arrows in your diagram to indicate more kinetic energy. And so more here just means thicker lines, thicker arrows. Hey, stop, move. So Can we tell a difference between these arrows and these arrows?
Yeah.
Definitely. Okay. So faster means more kinetic energy, slower means what?
Less.
Okay, so less kinetic energy. Good. I see some of you labeling these things. Tegan, I'm going to suggest that next time you make your diagrams much bigger. If you need another piece of paper, do it, but I want you to be able to see it neatly. And there's too much stuff to add to this to be able to see what's going on in there. Okay. So now tell me, this expanded. What did this do? Shrunk. Okay, vocab word. Yes, Kinsey? It contracted. So please write the vocab word contraction. Shrinks or pulls in. Remember I said that was a bad word. When we're talking about pressure from the outside, squeezing it. So there is a difference between squishing it and squeezing it and compressing it versus it pulling in on itself. Now, what's happening there that it's pulling in on itself? How are the particles moving? Yes, ma'am.
Slower.
Yes, the particles are moving slower, but what caused your water bottle to crinkle in on itself, to shrink in on itself? Yes, sir?
There is less force on it and it is not being pushed out.
Totally.
So it's going.
Yeah, we're talking about air pressure here. We're talking about the speed of particles inside, but also we're missing one thing. We also need the air pressure on the outside.
It is pushing in harder than the one side.
Yeah, you're right. So in this instance, we've got regular air particles. So I'm just going to draw regular air particles exerting a regular air pressure force, right? And so with that, I'm going to draw arrows that are like a little thicker than these. I should have drawn these arrows pretty thick. So I could like change that, right? We just make these go thin to indicate a really low speed. Good enough. These arrows are kind of going to be in between. All right. And so they're acting here as a force on the outside. And if these balance each other out, you know, like if we were to pop a hole in this or like puncture the bottle, break the integrity of the bottle, it would, you know, like even out because air would be allowed to flow in and out. And it would reach, what's that fancy vocab word?
Equilibrium.
Equilibrium. Okay, where the pressure is the same, right? But when we make the air inside colder, all right, when we're here, the force of these air particles meets inside, and it's, I'll try and match these up, and it's thicker. Can you see a difference here? Sometimes you can. Trying to match these guys up. Okay. And so since these aren't moving as fast inside, they're bumping with less force on the inside, but the outside air is the same. So you have those three vocab words down? And you have adjusted your diagrams to show this a little bit better. Okay, so we've got it big enough, we've got a process, it's neat, and we've got labels. Good? Okay, so now this question in red on a new loose leaf piece of paper. Okay, go. Also put the date today, would you please? The date is 2/1/22. So this question reads, what happens to a volume of liquid? We're talking about the particles when heated or cooled. And we're going to run an experiment to show that. All right, so what happens to a volume of liquid particles when heated or cooled? The last class did not get as far as I needed them to because they were talking over me the same time I was talking. I need you to pay attention. What did I change from yesterday? What's different about this question from yesterday's question? Jefferson, what's different about today's question from yesterday's question? Yes, I changed one word, liquid air, right? So today we're going to find out about liquids. Yesterday we learned about air particles, okay? Now we're talking about liquid particles and how they're going to act. So what happens when we add heat to a liquid and what happens when we cool it off? Yes, sir. Okay, we're going to do an experiment to prove it. Ready? This is how we're doing it. All right. We're going to modify our materials a little bit. We're going to do one glass bottle, one rubber stopper, one clear pipe. We're not going to use the bulb pipettes. You're going to do one index card. You're going to use tape, blue water, hot water, cold water. We're going to use 2 large of those cups back there. And then you don't need paper towels. This blue liquid will stain. Do not get it on yourself. Do not talk when I'm giving directions. So one person in your group will come get materials. I need to kind of arrange them. Look at how this is made. So you'll take an index card. And I believe the index card fits pretty nice going this way. Perfect. So you're going to tape it on like this and you can cut it in half. You're not looking up here, you don't know what I'm doing. So you can fit the index card on the side, you can cut it in half and you can tape it there. Then you will label, let's see, you will label the R after you get the blue liquid in. Okay, so I will have one person in your group come get index cards and start the process of cutting it in half. Okay, and then one person can come here and get the stoppers and stuff. I need to change this out. Wow. Tell you what, I need you to get new glass vials and then come back here and get the stoppers and the food. Okay, ready? Go.
Just us four get a card. We need pink. Pink's cool. Kids are weird. Whatever color. I have a card. If I cut it oh, work it. What's the juice? Oh, work it.
Hey, these are the groups from yesterday.
Right here. He's got it.
Okay,
Take
whoever
over.
I have one card. And
I got it.
Who are you?
Okay, I need y'all to sit with the group. Let's go.
Is it
The chair. They're not good. They stick. They wiggle. You have to take them with you everywhere you go. Sit in your groups so I can see where we're at. There was Ella yesterday. What did I do? So Sawyer, you're in that group. No, I'm sorry, you're in that group. Brayden, you're in that group. Sorry. Take your paper, please.
Do you want me to be in this group?
Yeah.
You got yesterday too.
Yeah.
Who's in that group together? Who was in your group? Okay, gotcha. Who was in your group? There's three. Yes, that's fine. Go ahead. Okay. So please get an index card. Cut it in half. Tape it to your stopper. You need to come get this stopper. Is this my ruler? I need a break. Stop moving. Listen to my directions. You have 30 seconds to follow previous directions. Get a card. Tape the card. Get your vial. Get a blue thing. Like, now I can't even know. Anybody have any questions about what you're supposed to do? Okay, go.
Nothing yet. We're supposed to.
Pretty good. Blue tray. Stopper with the two. Thanks for listening.
Oh, different there. You can do more. Yeah, me ants.
Okay, now you can come up and get your blue liquid. Send someone up with the blue liquid. Bring your tray so that I can pour it onto the tray. Leave the stopper there. The liquid to go about halfway. This isn't enough.
We have stuff. Stuff. Good. Everything seems good. Be careful with it. It looks so tasty too. Yeah. Yeah, I know that. It's leaky.
It will stain your mouth.
My mouth is forever blue.
Yeah.
You just want your shirt. What's? Yeah, down there.
Once you have your blue liquid, put your stopper in so that the liquid goes about halfway up.
Okay.
That's a-
They took it.
Good. And label it with an R. That means room temperature.
Okay. So I'm gonna turn this a smidge so that they can see your project. And then if we could work kind of here, where's your flag? That should be on there and it should be labeled already. Divide and conquer. You got your R? Yeah, where the blue liquid is, that's where you're gonna put your line with the R.
Okay, take it on.
We need the R.
Oh, we put the R when we got it on.
You good? You guys good? Are you guys good? Draw a line, put an R there, where the blue liquid is. Where the blue liquid is. Now, we need to look at the procedure a little lower down, okay? I'm gonna move your water bottle. Serenity, can you move the screen down just a little bit so we can see all of the procedure? Nope, so we can see the procedure, like
Oh.
move the. No,
Up or
no.
Over the cart.
cart? I don't know.
Scroll down. Is that what I'm looking, is that the right word?
No one told me what to do.
There we go, thank you. Stop talking. Okay, so we are going to place the bottle in 150 milliliters of cold water. We'll do this at the same time. So leave your vial, leave your glass bottle on the table. Bring your blue tray up and I will give you a little tub of water, like this. Okay, go.
That's not.
Why was it blue?
This is, that's not.
It was like a really blue. It was.
Okay, I will keep track of the time. Ready to put your vial in?
Yeah.
On your marks. I'm waiting.
Okay.
Excuse me.
Get set. Go.
Why don't we turn it this way so we do it?
Okay, it's been 30 seconds. We're gonna pull it out at 3 minutes, then I'll give you instructions on what to do.
It went down a tad bit. Nobody thinks.
It's been 1 minute.
Yeah, it's going down.
Minute 30, we're halfway there.
Oh, we're just staying here for. Oh, yeah. Oh, water. Let's see. Cool. Regular room.
been 2 minutes now. We have a minute left. As if I need you on the line. So all of the materials and your bodies need to be on this table.
Yeah, it went down the line.
Need to be on the stage. Like, actually move. A little bit more. Yes, see how your body is still on this table. 30 seconds left.
Sorry.
Please get your pencil or pen ready to mark. What you will do is you will pull it out of the cold water. You will put a line where the blue liquid is, and you will label that with a C. Make sure your line is equal. Go. Take it out, mark your line. Now take this off of your blue tray. Take it off of your blue tray. Yeah. Did you mark that with a C? Good. All right. Bring your blue tray and your cold liquid to me, and I'll trade it out for hot water.
Set that down there.
And no more water when I want to drink.
Like yesterday.
Yeah. That's what we got.
Set that down.
Yes.
Set it down.
Is it warm or is it hot?
It's just with two hands.
It's not that hot. Why are you touching me? Yeah, it's not hot. Before it hurt.
Is it down? You didn't last time up here, but this way and that's what
All right, we are going to place it in the hot water. Please get yourself ready. We're gonna do this for 3 minutes as well. On your marks. Get set. Go. We're gonna do it for 3. And as a matter of fact, if it happens to pop the top, we'll just take it out.
Did that happen?
Oh.
Did it make a mess?
No,
Smurf judo.
It's been 30 seconds.
no, it's Smurf joint.
Oh,
That went up like.
Look at this. Soft stomach goes like a volcano. Was that that line? Just the blue liquid at the very top.
Yeah, right here.
Oh, the weird part. That means you'll have the.
Oh, it's just been a-
Oh, so it's like
What the heck?
the more smart juice. It's
like
like
water.
water.
All right, it's been 1 minute.
Watch it for 10 seconds.
Yeah, just don't look at it. It'll be like a light stream. Now.
No, it's more like
Right.
watch
Okay.
it.
I need you to listen carefully. When this is done, you need to measure the distance between R and C and R and H. That's the next label that we'll use. Please stop talking over me. It's been 1.5 minutes. So when this is done, we'll take it out. You will label where it stops with a line and an H. Then you need to find a straight ruler. Use the centimeter side. Put the put the 0 at R and measure up and measure down. You'll write the measurements. It's been 2 minutes now. You'll write the measurements on the paper and then give it to a responsible person. You'll need to cut it off of the tube. So centimeters, for the cold, you may not get over a centimeter. So it will be 0 point and then the little lines in between the numbers. Don't touch.
You have 30 seconds left.
Oh my God.
Oh, dear.
Little pesos right here.
Over the top. Hey, it's already yet. Let's say take 30 seconds. As much as no, it's definitely
That's
almost 3 bars. It's 3 bars. To turn into a plate.
Okay, please get ready to mark, remove and measure. Go. Mark it. Remove it from the tube. Measure it. Mark it. Remove it from the tube. Oh, you might need to cut it off.
Oh, no. You've already done this. Both of ours is.
You may need to cut it. Okay, measure it in centimeters, please. There's one on that table. They have two. I'll take that one. I've got other stuff. Make sure you get. I'll take that one.
There we go. That's disrespectful.
Oh, that's on that table.
I look, wait a minute. Look at the bottom.
Yeah.
It's like,
It's 20. It's really
All right, the rest of you who are not measuring, please bring up the materials and set them on the table. Yeah. Plop it on.
0.7.
No,
they go up there.
It is just a stage. I mean, I would totally drink the blue liquid. No,
No, have a seat. This is 0.
0.10.
Yeah, 2.2 centimeters.
Yeah.
2.2 centimeters. How did you guys do? Good. 2.6 from to hot. You gotta go from room to hot and then room to cold. Measure, put your 0 on the ruler on R. What did you guys get, Nathan?
0.1 centimeter to CDR and 0.7 centimeters for the HR.
I'm sorry, so 0.7 from room to cold.
Yeah.
And what was from room to hot?
2.
2 centimeters. Okay, put C on. Label those and you're good. And how'd you guys do?
How one got 1.2 centimeters or 4.5 centimeters.
Sounds good. Please put that someplace safe. Take your note. Take your note. I need rulers, scissors, put back. I need rulers, scissors, put back. No one's leaving until the classroom is clean. Your scraps, could you please put them back up there? There's a vial cap on that table. Please put it up there. Write it down somewhere. Nope, we're not done yet. So there's 2 numbers. 15. So here's your room. So from room to C is how much? Okay, so what's 1.9? Room to hot? Okay, so 1.9 and what's the measurement? C, yeah. Okay. 1, 2, I do 0.8. I'm tired. And then 0.8.
Everyone's just in the white person.
This and that in your back. Now put the Thank you, we're good to go. You guys need a pass. Hey, where are you going?
Were you study hall teacher?
Cole, are you going the same place?
Yeah.
Okay, so Tegan and Cole to study hall from science. Today is 2/1/22, and it is fourth hour. Thank you. Thanks for staying and cleaning up. Okay, so stop sharing and